Hi everyone! Previously we implemented two methods which read data from the console and retry the operation if the input is invalid. Let's open the file user creation exercises and review these two methods. We can see that their code is really similar. In both cases they write a message, read one line from the console, and then parse the line into a boolean or a date. If this fails, the method calls itself recursively until there is no more attempts available, in which case the method throws an exception. The code duplication is a bit annoying, and moreover it makes these two methods difficult to read and test. So the idea is to capture the concept of retrying an operation with a single higher order function. And then we'll use it to refactor the code of readDateOfBirth retry and read subscribe to mailing list retry. To do that, let's open the file package.scala located in the same folder, as you can see here. So package.scala is a package object, which is a special object in Scala with the same name as the package where it is defined, so in our case, imperative. Package objects are used to share code within a package. For example, here I define a method greeting at the top of the object, and if I go to any file inside this package, I can call the method greeting without importing it. So it's quite convenient. Package objects are a workaround over a limitation of Scala 2, namely that all expressions, variables, methods, type aliases, must be defined within a class or an object. For example, I can't define a variable here. I can't say val x equals 0 because it's not within a class or an object. As you might have guessed, Scala 3 is removing this limitation, so we'll be able to define expressions wherever we want, and as a result, package objects will be deprecated in Scala 3. Until then, package objects are the best place to define utility methods like retry. Now let's have a look at this signature. Retry is a generic function which takes two parameters, max attempt and action. Max attempt describes how many times we are allowed to retry the operation. It must be greater than 0, otherwise the method will throw an exception. Action is a by-name parameter, representing the code we want to execute. And retry is in charge of evaluating action, catching potential errors, and re-evaluating action if max attempt allows it. In the file imperative action test, I wrote a few example-based tests, so let's open it. So these tests use the same technique we have seen in the lecture. First we define a mutating variable, counter, set to 0. Then we call retry with an action that increments counter by 1. This way we can observe how many times action is evaluated by looking at the state of counter. For example, in the first test, action always throws an exception, so we expect that retry will evaluate the code 5 times, the value of max attempt. In the second test, action fails twice before succeeding, so we expect the final result to be a success and counter to be equal to 3, because 2 evaluations failed and 1 was successful. Okay, so now it's your turn to implement a retry. Please come back to the package file and try to implement retry using a recursion. Okay, so retry should be very similar to what we have done before. So we'll start by this require method that will verify the value of max attempt. So we say that we want max attempt to be bigger than 0, otherwise we throw an exception, max attempt must be greater than 0. Cool. Next step, we want to evaluate action. So just by accessing this variable action, this parameter, this will trigger the evaluation. Now we know that action can potentially throw an exception, that's why we want to retry it. So we have to wrap this evaluation in a try in order to potentially catch an exception. And then we'll use an exhaustive pattern match to handle the failure. So if it's a success, then we are fine, we are really happy, don't need to retry. But if it's a failure, we want to retry. So we want to say retry max attempt minus 1, and we'll pass the same action. Cool. And we shouldn't forget to do this tail recursive annotation. Cool, so let's enable the test. And let's run them. Cool, so 2 tests pass and 1 fails. Oh yeah, so here what happens is that, you see this test verify that we define an exception. We're going to throw this exception every time, and at the end we expect to get back this failure, because anyway this code always fails. Now the problem is that we actually don't get this particular error. We get an illegal argument exception because max attempt must be greater than 0. This is exactly the same mistake we did before, is that when you're in a situation like that, if max attempt is equal to 1, we need to remember to throw this particular exception, because we don't have any more attempt. Max attempt equal to 1 means like we are done. We can't retry anymore. So we shouldn't even try. We should throw the exception in this case. Let's rerun the test. Cool, so now it works. So really, if you look at this code, it looks exactly like, it looks like the skeleton of the previous methods we implemented. So no surprise there. So before we move on, I would like to show you another refactoring for retry. Is that I don't especially like to have some logic about max attempt here and some logic here. So here we basically have an if then else based on the value of max attempt here and here. So it will be nice if we had it all together. At least it will be easier to read, in my opinion at least. So let me show you what I have in mind. I would like to rephrase this requires to say if it's lower than equal to 0 through an illegal argument exception. So in this case, it's going to be slightly more verbose. But the benefit of this is that we should be able to write all the logic based on max attempt in one place. So here we'll do the case where max attempt is equal to 1, and then we'll have a default case, which will be the recursion. So let me show you. Cool. So as you can see, first branch of retry is if max attempt is lower than 0, then it's invalid. Second case is if max attempt is equal to 1. This is the end of the recursion. We want to stop there. And third case is the default recursive case, where we want to evaluate the action and do something in case it's an exception. So I think this code reads better this way. Now the only thing we need to figure out is what should we do if max attempt is equal to 1. I think in this case, so what we need to do is that we want to evaluate action, but we don't want to retry it. So we don't even need to handle any errors, which means that this is enough. If you want, this is going to evaluate action, and if it throws an exception, it throws an exception. We don't do anything. So let's run the test. It still passed. Awesome. Okay, next step. Now we're going to go back to user creation exercises, and the goal is to refactor read subscribe to mailing list retry using retry. So please pause the video and try to clean up this code, and again, don't forget to run the test to verify if you haven't broken anything. Okay, so let's try to refactor this code. So we'll start by calling retry, and we'll pass the value of max attempt, like how many attempts do we have. Then the second argument of retry is a block of code that we want to retry. So let's move all the logic there. So we don't need require, because require was checking the value of max attempt, and now it's retry who is in charge of this. We still want to write something to command line, read it, parse it, but we don't need to do the recursive call anymore. So we can remove all this piece of code, and now retry should handle this, right? Let's run the test to see if it works. So it doesn't even compile. This is because this function has a tail rec annotation, but now it's not recursive anymore. So you can only have a tail rec annotation if a function is recursive and tail recursive. So let's try again. So some tests failed. This is exactly what we had before. So the result of the test is correct. We did do the retry. That's fine. but the output, what was printed on the console, is not correct. So we expected to see the question followed by an error message and the question again, but we only had two questions, so we forgot this error message in the middle. So it's because we have been a bit too aggressive when we remove code, so let's roll it back a little. So we still need to remove the tail reg. But we do need to have the try-catch because we need to write something to the command line in case there is an error. Now, we don't need to differentiate based on the value of max attempt because this is handled by retry. And we don't need to do the recursive call because it's also handled by retry. But here we do need to restore the exception in order for retry to be aware that it was a failure. So let's rerun the code. Cool, so now all the tests pass. Okay, that's an improvement. Now the method is not recursive anymore, and we don't have to deal with the various edge cases around max attempt. However, the overall logic is still messy. For example, this whole block of code here is just there in order to print a message to the command line in case an error occurs. So it's quite difficult to read. So what we could try to do is to capture this pattern using another higher order function. I called it onError. So if you go back to the package object, you will see the method onError defined here. It takes two parameters. The first one is the action we want to perform. It's also a by-name parameter like we used in retry. The second parameter is a cleanup function, meaning that it's something we want to execute when an error occurs, but we'll discard its result. That's why the return type of cleanup is any. For example, in our case, we plan to use a cleanup function to print a message on the console. Okay, so please pause the video and try to implement onError. Okay, so for once, let's try to do some TDD. So let's open imperative action test. We don't have any test yet written for onError. So let's do this right now. So what do we want to check? Well, ideally, there are kind of like two main scenarios. Either the action we pass to onError is a success, or it is a failure. So let's try with the interesting case first. In case it is a failure, what do we expect? So we're going to call onError, and we'll pass it an action block, and we'll pass it a cleanup function. So we want the action to be a failure. So for example, we'll just throw an exception. So we can say new exception, boom. Okay? Now in the cleanup operation, we need to do something. So this takes an exception here. So this is an exception. And we need to write, we need to do something within the cleanup code. So in order to monitor that this action has been called, we use this trick we've done before. We create a mutating variable, counter, and what cleanup is going to do is going to increment this counter by 1. This way we'll be able to monitor if cleanup has been called or not and how many times it has been called. Because if it's called twice, then counter will be equal to 2. If it's called once, counter will be equal to 1. Actually, we don't need the exception, so it will be like that. Cool. So then we want to assert that this, after calling this function, counter should be equal to 1. This is one thing. So we want to verify that the cleanup operation has been called. And we want to verify that this onError has thrown an exception. So we can say like this will be the result. So because throwing an exception, the only way to catch it is to use try. So we're going to use try around it. And what we want to verify is that the result should be a failure, right? We can even be slightly more precise. We could, create a variable and say this is the particular exception that we threw within onError. So this exception is the one we threw, and I just extracted it. And here what we want to verify is that result should be a failure with this specific error. This way we know that onError shouldn't change the exception that was originally thrown. If the actions thrown error on error should rethrow it at the end, exactly unchanged. Okay, so that's one test. Another test we can do is in case, the same thing, but in case the action is a success. So if you want, if action is a success, so we are not going to throw any exception. This is going to do like, basically, for example, we can return a string, like let's say hello. This is something like a constant. And what we want to verify here is that this should be a success with hello here. And counter should be equal to 0. So in this version of the test, we verify that if the action is successful, the cleanup function hasn't been called, that's why it's still equal to 0. That's how we monitor it. And we verify that the result of on error is a success, because the action was a success. Cool, so now that we have these two tests, what we can do is run them, and we expect them to fail because we haven't implemented on error yet. Yes, so this is failed because it doesn't get the correct error. It gets a not implemented exception because we haven't implemented yet. And same here. Cool. So now let's implement it. What do we want to do? So on error, we want to evaluate action. So in order to evaluate a biname parameter, we just access it. Now we know that this can throw an exception, so we are going to wrap it with a try, and we'll use an exhaustive pattern match to differentiate based on the success or failure of this action. So if it's a success, then we are really happy. We just keep the value. And if it's a failure, this is where we kind of need to do something. So if it is a failure, we want to call the cleanup operation. Okay, and then what do we do after that? Well, we want to rethrow the original exception. So we're going to do throw exception here. Okay, let's run our test to see if it works. Cool, so the test passed. And just to show you, if we were going to command cleanup, for example, if we had forgotten to call the cleanup operation and we run the test, our test should be able to detect that we made a mistake. Yes, indeed, it failed to compile because it said that the counter was expected to be 1, but it was actually 0. Because, so you see that it's quite convenient to use this mutating variable technique to detect if an action has been called or not. Cool, so now that we have an implementation of on error, let's go back to user creation exercises, and let's try to simplify the code of read subscribe to meaningless retry. Especially this part that we had this complex error handling logic just to print a message at the end. So could you please pause the video and try to refactor this function? Okay, so now that we have on error implemented, we are going to call it here. So we have two parameters, the actions and the cleanup operation. So what is the action? It is this parsing logic that can potentially fail. And what is the cleanup operation? It is writing a message to the command line. So we don't actually care about the exception in this case. Cool, so let's run the test to see if it still works. Yes, it does. Cool. So now I'll let you pause the video and try to do exactly the same refactoring for read date of birth retry. Okay, so it should be like fairly identical. We know that we want to use retry. Here we know that we want to get these actions that we want to perform. We know that the parsing logic can fail, so we'll use on error. And I will just write it in line just to show you how it could look like. Here, we'll do it like this. And we remove the tail rec annotation because now this method is not tail recursive anymore. So as you can see, we don't have to specify the name, action, and cleanup. I do think that it helps, it makes the code slightly more readable. So I would do this probably in practice. But we don't have to. So let's double check that I haven't broken anything. Yes, it still works. Great, so now the code of read date of birth retry and read subscribe to meaningless retry is much clearer. Retry handles evaluating a block of code until it succeeds or until the number of attempts has been exhausted. While on error allows us to define a cleanup operation that only happens when a piece of code fails. Additionally, the code of retry and on-error was much simpler to test, because we didn't have to deal with the console interface or generate a specific values for the parsers to fail. Instead, we used a mutating variable to monitor when and how many times the action is evaluated. Cool, so I hope you enjoyed this video, and if you are extra motivated, you can find some bonus exercises at the bottom of package.scala. So these exercises are not covered by the video, but you can find all the answers in the answers module. See you soon.